Mindenkit, Szekely Tamás vagyok, mint az ugye elhangzott, és a bitcoin rossz indulatú felhasználhatóságáról fogok beszélni, illetve hát végül is ennek a körülményeiről.
And about the circumstances of that malicious use and how it is set up. The first round, the Bitcoin itself. Bitcoin itself, what is that? How does it function? As time allows, I will go into some technical details. And then just to mention, just to the limits of one slide, the Tor network, and on that basis we can build the laundering of money, which is in the world of Bitcoin much more making Bitcoin anonymous by various mixing services rather than actual money laundering. And once we have quite clear laundered money, then what can we do that money on the black market? Now, a few ideas about Bitcoin. Bitcoin is maybe the simplest and cheapest way to exchange money electronically. It is very simple because just a few clicks and then we can start already our transaction, and very cheap because practically it is free of charge. There are, of course, a few exceptions if we can get some yield some commission, but otherwise it's a method of payment free of charge. It was a guy called Sashimoto who claimed to have initiated it, and it was 2009, January 3, that it was effectively implemented. I say that it was the person who called himself Sashimoto because although he called himself Japanese, but in some cases he's using some very good literature, English language, and some occasions American language. So it was still impossible up to today to find out who that person effectively is. Now it is a fully decentralized system, which means, first of all, that it is that with one single server you cannot destroy the system, but it also means that there is no central authority who would control the whole system. There are no various levies and taxes that the user would have to pay. It is really fully free, and it is the participants who operate it. As there is no central authority to defend it and to circumvent it with different types of laws and regulations, which are basically aimed at various people who would like to circumvent it and cheat with it. There is another system. There is a very good system. It is on a pictographic basis that it is conceived. There are elliptic circles which are used, which is a PKI infrastructure, and SH62 algorithm, which is very well known in the world of the Bitcoin. There are several advantages. If we look at bitcoin.org, I would not like to read them up all. What I would talk about is security and identity protection. This was so good that I just couldn't miss it from my slide. This is something no PC compliance. The Bitcoin emission by the system takes place in the following way. It is a emission which is halved every 4th year. So 25 Bitcoin is put into circulation every minutes. And then what it means that because it is the emission is stable rate, there is no much inflation. If we follow the curve up to the end, then basically where emission is reduced to zero, then Bitcoin will cease to inflate. And as all of the currencies like this one is measured, and all the other currencies are going on inflation, so the Bitcoin is already deflated. It is worth more and more compared to the other currencies. And once we talk about the value of Bitcoin, Bitcoin has a real value. There are several sites dealing with that, with the fact that the name of Bitcoin should be changed into other names like US dollar, and the mongops, I will show that to the extent of some slides, that graph is from Mugdox, and it shows the exchange rate. It is not as stable as any average currency. Fluctuation is a little bit higher. Presently is $136 around that today. And if we talk about instability, then I would like to show what happened in the month of April. Just because the servers of Mangops for 2 days were inaccessible. And then from 266, the rate was dropped back to 60 odds, and it was a very sharp drop. And the first idea was that maybe it was a server of Mangops which received an attack, and that it was not an attack, but it is their page which is so popular that they just couldn't resist the charge. Mangox name is the magic it's an online version of this game. Magic the Gathering exchange is basically this is the abbreviation of that long name. But the exchange of cars was dropped, and it was the Bitcoin stock exchange which took over this role. How can we obtain a Bitcoin? We need a wallet. In the wallet, we can have software-based or online. I will talk about the software version because we can get closer to the cryptograph, because anyone can register there, sign in there, and among the softwares, these are the most widespread and most relevant, and this is which ensures the basis for the system. If we select this, then our client will download a archive of a couple of megabytes, which includes all the transactions which have taken place. Multibit is much more efficient when it comes to sources. There are less features, but the charge to the load on the machine is less. And of course, the last one is the most secure. I tried it on Windows. We have only the beta, but I think it is worthwhile to look to follow that with interest, how it will develop in the future. This is how Bitcoin looks like. You can see that I created 3 wallets. 2 of them 260 can be created, which is quite a big number. And I mentioned that it is a PK infrastructure that it is based on, so we need a public key. And the public key usually said is that it's the address itself, which is almost true, with the only addition that the public key should be still #256, and this hash should be, the checksum should be added, and then it will be coded. And finally, we shall obtain about a 33-character string, and this is our string, which will be our public address. This is 160, which is the outer hash that we will define the number of the addresses that we can create. 2 on the 256, which is says that if all of the dust particles of the Earth would be added by, complemented by the same amount from another planet, then it would still not be that number. So the system does not check when it creates a key pair, because there is such a choice available. So one other element in this respect, this is in detail. If anybody would like to look it back from video, there is a good link which you can also use for developers. You have a detailed description of how the Bitcoin protocol functions. Private key. What it is from the wallet.com. It's a Windows and Linux version. Wallet is where we have everything, the public key also, and also all the pieces of information that we require so that to transfer our wallet from one PC to another. So all is included in that file. And everything can be backed up, and it can be protected by a password. And of course, if we have larger values, then it is also possible, value amounts, to store it in various folders. And then let's look at a transaction, how it looks like. At first sight, it's not nice enough, but it's finally fairly simple. So first of all, we have to clarify that Bitcoin does not keep on record the balance of the various transactions, but the transactions are open, transparent. It is visible for all of the peers. Now, how many Bitcoins I have, it can be certified by the transactions I receive. And if it is with somebody else, then I see my transaction where I was the beneficiary from an earlier transaction. And then, and also the public key of the next owner, and I will then hash them together, and I will sign it with my private key. In this way, so this has two functions. One, that because I signed it with my private key, my public key can be used to check it, counter-check it, anybody else can counter-check it, and I can also do that. As I send it to all my peers, and they also send it to all of the peers, then all the peers can see if there was any coverage for that transaction, any credit for that transaction. Another signature, which also works as a fingerprint, which also ensures that the transaction cannot be modified, or if a modification could be taken place, that would come up to the forefront. That would be quite clear. Now, Bitcoin protocol is already well known. So I can also show it to you how a transaction works. Now there is an input there and two output transactions over there. This is quite typical for the world of the Bitcoin, because if we look at specific examples, ProfExplorer.com is the place where we can look at all the transactions. It is an online platform where you can look for it. And this picture is also from there. I just manipulated it a little, but this is where it comes from. And there we have a specific example. There is an incoming transaction which is the worth of 3 Bitcoin, but it is only 1 Bitcoin I would like to transfer. So we should decide what would happen to the 2 Bitcoins remaining. Normally, we shall transfer it back to us, and if we didn't do it, then those 2 Bitcoins would disappear for us. So this is a typical thing, that there are 2 outputs, and one output is our own address where we transfer the money back to us, ourselves. Of course, because this is a network, peer-to-peer network, there are plenty of problems that we have to solve. For example, we said that each of the peers will validate the transaction, the ongoing transaction, and evidently that whether this money was spent twice or anybody would wanted to abuse with it, the only way is that I accept the first transaction valid, and if anybody else would like to try to adopt the same transaction as valid, then it will not then it will become invalid. So, for example, Mallory received a Bitcoin from Alice, and who would like to play with it. We send to Bob and Theodis, and we'll also send to himself. Now, the peers on the green line think that there is another transaction, a valid transaction, that the transaction on the red line. And basically, in that case, what will happen that from the point of view of the system, it is quite the same where this 1 Bitcoin is, and if it can be checked and used, then it is also the same for the users. But this conflict situation has to be solved. And how is that solved? It's with a specific system, but Bitcoin, as we said, is a peer-to-peer based decentralized system, and there are some very you can only find some very interesting complicated solutions, and this is why the blocks there are. The blocks are grouping the transactions, that in each block you have the hash of the former block. So they form a chain, and if anybody would like to interfere, then it will be quite visible, because this serves as a safe element. Now, we have to also make it more difficult that anyone could play with the block, because with this block, because otherwise all types of transactions could be undertaken, and this is why the concept of proof of work has been created, which is a complex mathematical operation, which is much more like drawing lots. It requires time, and this is the block info that we have, where there are all the data of the block, for example, the hash of the previous block, the transactions, and some other block-specific information. And whoever would like to create the block would have to attach some random bits that if all of this is hashed twice with AS256, so that more processing would be needed for that, then the whole hash which we obtain should be smaller than the actual target. The target is a 256-bit number, which is gradually decreasing as the transaction capacity of the Bitcoin increases. So that means that the system will reach that one block will be created in 10 minutes time. If everybody would purchase the same things and count blocks, then the target will be set in such a way that it will take 10 minutes to create the block. So whoever would like to mine the blocks and would like to hope for getting some money, they are fighting against each other, but that is a topic I will talk about more in detail later. We also mentioned that the blocks perform a chain.
What happens if two peers create a block simultaneously? Well, the winner block will be the one that will be continued, so always the longest chain will win. A Bitcoin transaction counts as reliable roughly after 6 blocks or 1 hour, and it's trying to cheat by quickly generating a long chain, because this would require a computational capacity. So this is a peer-to-peer network. If I want to be faster than everybody else, and I'd have to compete with everybody else, which would require a huge computational capacity and a huge dose of luck. So it's not really something that is worth trying. And even if I had the compute capacity available, and I could achieve a lot more Bitcoins by trying to mine them than by trying to cheat. If 2 blocks are generated simultaneously, they will still be different, because the one who decodes the proof, the block, the proof of work, he will credit himself with the first transaction, which is 25 Bitcoins plus the amount within the block. So these are the 25 Bitcoins that allows new Bitcoins to be generated. So Bitcoins get into the system by these blocks being generated. When it was first invented, this whole concept, they invented it for a processor-based mining. Then came the GPUs, which provided a multiple of CPU capabilities. And currently, the new hot thing is ASICs. I tried this mining. A 7870 ATI video card was run for 3 weeks. The computer consumed roughly 250 watts, so these 3 weeks cost me 5,000 forints, and I was able to scrape together $6 to $7. So those who try to mine with the GPU will not get far. The 7870 card provides the exact same compute performance than the basic ASIC you can get. The video card costs 60,000 to 70,000 forints. An ASIC costs roughly 6,000 to 7,000 forints. The video card consumes, together with the computer, roughly 250 watts. And an ASIC, if I plug it into a Raspberry, then the two together will eat 5 watts. So that's a huge difference. And this also shows in the increasing compute capacity for mining Bitcoins. In the past 2 weeks, the Bitcoin compute speed grew 4-fold, which is evidently a result of the ASIC spread. If we had looked at the mining rig before Bitcoin, this is what we would have found. If you would have searched for the term mining rig, in the past week, mining rig has become the Bitcoin-related term lately. So you need to scroll way down in Google to find anything else but Bitcoin mining hardware. You can mine alone or on a pool. The biggest such pool is BTC Guild. Pool means that multiple computers uh, try to create a block by unifying their forces and then distribute the amount they may have achieved to deviate up among themselves. This decreases variance. Income will be much more plannable. I may buy the best ASIC and I won't get results for a whole year. Hunting in a pool gives you a lot more chance. There is a CG miner application. It knows all the GPU, most ASICs, so it's very compatible piece of software. And BTC Guild's website gives a lot of help for workers to manage workers. Workers are the computers actually performing these computations. You can download graphs and similar. So it's very useful. Let's say a couple of words about Bitcoin's anonymity. I mentioned that all transactions are completely public, as against the transactions normally used in the banking world, where only I and the beneficiary know what is going on. But our address is not necessarily public. On the contrary, we'd like to make the Bitcoin wallet address independent of our own addresses, if we want to be. So anyway, it is exactly the opposite of what we see in a traditional banking transaction, where others don't know what our bank account number is, but the transactions are not public at all. Our anonymity may be impaired at many places. For instance, when we buy a Bitcoin or when we buy something on the internet and provide our own address, or when we carry on transactions that make us traceable, or I may provide my Bitcoin address at a forum where otherwise my person is known, but I'm known personally, so I need to watch out for a lot of such stumbling blocks. In Bangkok, in order to buy a Bitcoin, we need a proof of identity. This is like it could be a driving license or an ID card, and a proof of residency that proves where you live. As far as I know, it could be a public utility bill or something else that identifies you. So they have all my data. They also know which of my wallets they are transferring money to. They do not accept credit or debit cards at most such sites, only wire transfer, or there may be one solution simply because if a Bitcoin has been transferred, it cannot be undone. While during a credit card transaction, you may try to get the bank to reverse the transaction. With Bitcoins, this does not exist. I promised something about Tor. I believe that most of you know it and have probably actively used it, so let me just outline the basics. Alice would like to communicate anonymously, so she reaches the first Tor node anonymously, of the database of which has been allotted to her previously. And within the Tor network, this traffic is routed to randomly, hopefully preserving her anonymity. There's one more other important aspect of Tor. You can use it to reach sites that you otherwise cannot. The onion top-level domain is an anonymous domain that provides services that you don't find in the clear. I found a picture that shows you the situation. If you use your browser normally, then you are surfing at the top of the ocean. In order to dive down to hackers and other nebulous people, you will need to use the Tor network. This can be done either with a plain Tor browser which is a modified Firefox, but you also have a modified Debian operating system that you can use, which and I think it's even better. Once our public IP address is covered, the only thing that we need to anonymize is the transaction. So we need to anonymize a wallet. Here we have Alice and Bob, but Alice's and Bob's wallet, but obviously Bob's wallet could be replaced with Alice's second wallet, so Alice could also transfer to herself. The only target is to make the transaction untraceable. So the transaction must be void of any information identifying the sender or recipient. All transactions are public, and therefore we need to insert a central provider, a mixing provider, by Alice transferring from her wallet 1 and Bob from his wallet 2 without any link between the two wallets. This seems to be okay and untraceable, although there are methods to try to trace them back. This is a very simple solution, because if you're looking for transactions pretty near to each other, then you'll probably find some, which is not necessarily a good thing. Obviously, there are tricks to protect against this. What would happen if Bob had two wallets and we just split the outgoing money? This would immediately make it more difficult to identify Bob. And the mixing provider itself can transfer money from various wallets, and you could increase the number of green lines to any number you want. And you can also separate these transactions in time, with one transaction following the previous one only days later. So there's a node algorithm that can actually connect these two. There's a very good white paper that you see at the bottom, very useful reading. He tested these three mixing providers, and he found that BitLaundry allowed input and output transactions to be coordinated or to paired up. But with the other two, it was very interesting to see the chain through which transactions pass. Bitcoin fog is only accessible through a Tor network, although they also have a portal in the clear, but there they only offer the anonymous address and ask users to use that. And blockchain info is accessible from anywhere, and these services do have a fee, and blockchain.info is lower, but it's only a very low fee of about 1.5%. And obviously, if you are looking around on the Tor network, you can find the various mixing service providers that promise you a lot of things. There was one I found that said don't use Bitcoin fog because that's NSA's website. And while we are at the risks, there are risks. A mixing provider is a good solution, but as everywhere, you need to be very careful. You can never know. Well, this is a very complex transaction string that the mixing provider is doing. It obviously needs to log all these transactions somehow to correct any errors that it may commit. Will these logs be deleted? And if yes, then when? You will never know. And if there is a problem, a legal problem, will the mixing provider provide our data to a requesting authority? That's a question. Any organization may be behind such a mixing provider and will see all transactions and even the items that you buy for your bitcoins, allegedly anonymously. Well, we could use more mixing providers in series. One of them will be reliable, hopefully. This has the disadvantage that it increases the costs. So the guy who wrote the previous white paper calculated that the handling costs will go up, obviously, if you concatenate mixing providers. I also mentioned that these transfer pairs can be separated in time. What happens if we have two? Well, if a missing provider goes bankrupt and there is an example for that. Insta Wallet had that fate. You can read up on it. And just a comment. Bitcoin's basic principle is that it is peer-to-peer, decentralized. And what is a mixing provider, if not a centralized point? This actually seems to be defeating Bitcoin's basic philosophy. So once we have done all of this, then we have an anonymized tender. How can we spend it? You can buy drugs, guns. I haven't found any 50 caliber, only smaller. But there's a lot of things you can buy for your bitcoins. As you see, all prices are quoted in bitcoins. You can buy driver's license, credit card, and a lot of stuff just to show you how many things you can buy if you want to. Obviously, I'll expand a bit more on IT-related items. Let me add one more comment. You may have read it. On the 2nd of October, this site was taken offline. This is Silk Road. This was the Silk Road site that was taken offline, has been around since 2011, and this was the largest site offering drugs and similar. I just did a lot of screenshots, and one day this was the screen that greeted me, and I read the news the next day. So in a couple of hours, Bitcoin's value fell by about $20. What are the IT-related possibilities that we can use it for? Well, as a customer, we can buy a lot of things. You can buy here exploits, DDoS service, spams, whatever you wish. And why should we stop so soon? We might need it. We can also build our own botnet. There are multiple business models. Let me detail one and mention another, but these are the most characteristic ones. Couple of advertisements. I was looking for DDoS ads. For example's sake, here you see 20 gigabit per sec bandwidth offered. I don't know about too many servers that are able to withstand 2 gigabit per sec. It's not even expensive. 2 hours is enough to make that server crumble. And you find a lot of such advertisements. I could have found even a lot more, but it's just for showing to you. And if you want to build your own botnet, this is one solution, pay-per-install service. The other one is the exploit service, both of which will be discussed a bit, just to show you what it looks like. In the case of pay-per-install, you have the clients on the top. All of them is running a little software that it wants to install on X number of computers. You can even specify the geographical region where you are hunting for these computers. The clients give their software to the PPS service provider, and that provider will send these small downloaders to the clients it wants to infect, and those will then download what is needed. The PPS service provider may also outsource the dirty work to so-called affiliates. And the ClearNet, you can see that some parties are looking for reliable affiliates. Obviously, cost efficiency optimization causes such affiliates working for multiple providers, and you may not be sure that your PPS provider may also infect your computers that should be working for you. It may infect your computers with stuff from other PPIs. This is the essence of this service in a few lines. There is another white paper about that, a very good one, with test results, also describing the test environment. And what I haven't told you yet is that, according to the white paper statistics, 12 out of 20 malware are spread in this model, which is significant, I think, and they use all methods for spreading this, drive-by downloads as well as embedded malware in digital software or social engineering. So it's these PPI providers often change their names. The provider stays the same, the one who is running the business, but the name is often changing. These are some ex-PPI providers about whom you can read about the link at the bottom. These PPI providers offer themselves in the clear. I haven't provided a real screenshot about them because it's very difficult to decide whether they are real PPIs, they are bad guys, or just want to install some malware. And the second thing I want to talk to you is exploit as a service. This is about the victim being redirected through a lot of redirections to an exploit site, probably normally a black hole place. 29% of all malicious URLs are lead the victim to a black hole exploit. This is the exploit kits based on a browser plugin vulnerability to upload some malware on the victim's computer. It also is a pay-for-service, obviously with another white paper that describes this specific exploit as a service. Yeah, 29%, that's what I said. And this is a very easy to manage web-based solution for clients. The difference to BPI is that in exploit as a service, you have malicious URLs pointing to malicious servers, and machines are infected only through drive-by download. And between the two halfways, there is a third possibility, which is a bit of this and a bit of that, and yet neither of the two. And this is the so-called traffic BPI, which is a PPI, but only uses drive-by downloads. Or it's an exploit with the aid that once you have bought the service, the server where the exploit pack is running, it even provides you the victim. You don't have to trouble yourself with trying to spam people, directing them to your places. They hunt the victim for you. If you rotate this in picture by 90 degrees and these three layers fall into one another, then you practically get PPI.
So here we talk about three separate solutions. Basically, of course, the picture is much more complex because they are more resembling each other. Now, this is one of the last things which I would like to show to you, this picture, because this is so full of ideas, and it's really quite, all of the elements are here, and it has its place in my lecture, and I read about it, of course, also in an article, that the bank robbers are using a car. It's not, doesn't doesn't mean that a car is a bad thing. So Bitcoin is also a solution which can be used for bad purposes, but it can also offer good opportunities for caritative purposes. More and more of them have a Bitcoin address, and you can also make donations in Bitcoins. Now, if you liked what we talked about, these are the links, the references which are the best. Maybe they can be very useful. They explain very well the topics, and of course also as for the after the 41st slide, there may still be some questions, and then the 42nd one is here, but I will be, of course, here all day long, and a couple of hours which we still have left, and then we can still come back to the topics. Thank you for your attention.